The year was 1859. It was a time when the world was changing fast. People were building things. New ideas were everywhere, and one of the newest, most amazing things was the telegraph. Imagine a world where news traveled only as fast as a horse could run, or a ship could sail. Then, suddenly, messages could cross continents in minutes. It was like magic. Telegraph lines were strung across land, connecting cities, towns, and even countries. These lines were the nerves of the planet. They carried important business news, government decrees, and personal messages. Operators sat in small offices, tapping out Morse code, making dots and dashes that translated into words. They used batteries to power their systems, sending electricity down the long copper wires. This electricity made a clicking sound at the other end, allowing another operator to write down the message. It was simple, but incredibly powerful. Most people didn't know much about electricity itself. They just knew it worked. They didn't think about where it came from or how it really behaved beyond what was needed for the telegraph. The sun, for them, was just a light in the sky. It rose, it set, it warmed the earth. It helped crops grow. It gave light to see by. No one thought of the sun as a giant, fiery engine that could affect things down here on Earth, especially not something as delicate as a telegraph wire. In 1859, the telegraph network was still pretty new, but it was growing quickly. Operators were proud of their work. They were at the cutting edge of technology. They connected people, they brought the world closer. It was a truly revolutionary time. But this new technology, with its long, sensitive wires, was about to face something no one could have imagined. Something from space, something that would show everyone just how connected everything really was, even if they didn't understand it yet. It would be a lesson learned the hard way, a very surprising lesson, and it was all because of the sun. The sun, which seemed so constant and predictable, was about to show a different side of itself. A side no one had seen before, or at least no one had recognized the true power of. The world was just starting to wake up to the forces around it, both on Earth and far beyond. The telegraph was about to get a truly unexpected test. A test from outer space, from something that looked so calm and peaceful in the sky. The people working the telegraphs, the inventors, the scientists, they were all focused on making their machines better, making the connections faster. They were looking at the ground, at the wires, at the batteries. They were not looking up. And that's where the problem and the wonder was coming from. That's where the big event of 1859 was quietly building. No one knew it was coming. No one could prepare. And when it hit, it really showed what this new fragile system was up against. It changed how people thought about the sun forever. Or at least, it started to change it. Because even after it happened, many years passed before we truly grasped what occurred. But for those telegraph operators in 1859, the experience was immediate and very real. They had their routines, they had their tools, they had their understanding of how electricity worked. And then, without warning, all of that was challenged. The simple act of sending a message became something else entirely. Something strange, something powerful, something a little bit scary. The telegraph offices, usually quiet places of industry, were about to become theaters for a cosmic show. A show that put their new technology through a stress test like no other. A test from the ultimate source of energy in our solar system, the sun. So, in 1859, the stage was set. A world eager for communication, a technology just finding its feet, and a sun that was about to unleash something extraordinary. The telegraph, the pride of the age, was about to get a shock, and it would teach us a profound lesson about the hidden connections between our world and the vastness of space. A lesson that still echoes today. The sun started acting up, not in a way most people would notice right away. But scientists, the few who were really watching, saw something strange. On September 1st, 1859, a British astronomer named Richard Carrington was sketching sunspots. Sunspots are dark areas on the sun's surface. He was drawing them, like he often did. Then he saw it, a sudden, blinding flash of light on the sun's surface, right near a large group of sunspots. It was incredibly bright, much brighter than anything he'd seen before. He quickly called for another observer to witness it. They both saw it for about 5 minutes. It was a solar flare, a massive eruption of energy. This flare sent a huge burst of radiation and superheated particles into space. It was like a giant cosmic sneeze. These particles, moving incredibly fast, were heading straight for Earth. Normally, it takes a few days for these particles to reach us. But this one was especially powerful and fast. It was what we now call a coronal mass ejection, or CME. A little over 17 hours later, the particles hit Earth. When they arrived, they slammed into Earth's magnetic field. Our planet has a natural shield, a magnetic bubble that protects us from most of this stuff. But a storm This big was too much. The magnetic field got rattled, twisted, and compressed. This disturbance created what scientists call a geomagnetic storm. The most obvious sign of this storm was something beautiful, but also terrifying for many of the aurora. Normally, the aurora, or northern and southern lights, are only seen near the poles. But during the Carrington event, they were seen all over the world. People in places like Cuba, Hawaii, and even Colombia reported seeing incredible red and green skies. The lights were so bright that people could read newspapers at night just by their glow. Miners in the Rocky Mountains woke up thinking it was morning and started making breakfast. Sailors were confused, thinking dawn had come early. For many, it was a wondrous sight. For others, it was scary. Some thought the world was ending, some thought it was a sign from God. They had never seen anything like it, and they had no scientific explanation for it. They just saw the sky ablaze with color, unlike anything they had ever witnessed. It was a silent, magnificent, and very unsettling display of the sun's raw power. The celestial light show was just one part of the event. The more disruptive effects were happening down on the ground, affecting the new technology that was supposed to make life easier, the telegraph. The energy from the sun, funneled down by Earth's magnetic field, created powerful electrical currents. These currents weren't just up in the sky, they were flowing through the ground, through the ocean, and crucially, through long metal conductors. Like telegraph wires. The telegraph system, with its miles and miles of copper wire, was perfectly set up to act like a giant antenna for these currents. And it was about to get a massive, unasked for power surge. The sun's fury was not just a light show. It was an electrical surge coming from space that was about to disrupt the most advanced communication system of the time. This was the true shockwave of the Carrington Event, hitting directly at the heart of human progress. And the telegraph operators were right in the middle of it. They were the first to really feel the sun's anger, even if they didn't know where it came from. The sky was alight with brilliant colors, from deep reds to vibrant greens. People watched in awe, or sometimes in fear. But for the telegraph operators, the sky show was just the backdrop to something much more immediate and dangerous happening right in their offices. As the geomagnetic storm intensified, the long telegraph lines stretching across the land started picking up electrical currents. These weren't the small controlled currents from their batteries. These were huge induced currents flowing directly from the ground and through the wires. We now call them geomagnetically induced currents, or GICs. The effects were instant and dramatic. Telegraph lines stopped working, operators found their messages garbled, or the lines went completely dead. But then, things got really strange. Some operators noticed that even with their batteries disconnected, they could still send messages. The storm itself was powering the telegraph lines. The energy coming from space was so strong that it was acting as the power source for the entire system. Messages were being sent, some of them perfectly clear, using only the aurora's power. It was like magic, but a wild, unpredictable kind of magic. Operators reported sparks flying from their equipment. The delicate paper tape used to record messages sometimes ignited. There are accounts of operators getting mild to severe electrical shocks. One operator in Boston described getting a severe electric shock and seeing a stream of fire pouring from his instrument. Another in Washington, D.C. said the magnet of his instrument was so hot it was red hot, and that sparks issued from it. In Maine, a telegraph office operator reported that he could work his line for 2 hours using only the aurora current, transmitting messages that were even better than when worked by battery. He saw a sheet of flame coming off his stylus and paper. Now, did it set telegraph offices on fire? This is a crucial point. Historical accounts suggest that while sparks were common, and small pieces of paper or telegraph tape did ignite, there are no widespread reports of entire telegraph offices burning to the ground. The fires were generally localized to the equipment itself or the paper used for messages. Imagine a small spark igniting a bit of dry paper. It could cause a small flame, which an operator could quickly put out. It was more about these intense localized ignition events rather than a widespread conflagration. The danger was real, the sparks were real, and the small fires on materials were real. But the image of an entire building engulfed in flames is likely an exaggeration of what happened. However, the experience for the operators was undoubtedly terrifying and dangerous. They were dealing with unknown, powerful electrical forces. The equipment, designed for small, controlled currents, was suddenly overloaded with massive surges. The wires themselves, acting as giant antennas, were conducting these powerful, uncontrolled currents. This led to fuses melting, components overheating, and the very real threat of fire from those sparks. The sound of constant clicking and buzzing, combined with the flashes of light and the smell of ozone and burning paper, must have created a chaotic scene in many offices. The telegraph operators showed incredible bravery and resourcefulness during this time. They didn't understand what was happening, but they tried to keep the lines open. Some disconnected their batteries, realizing the lines were powered by something else. They were the first human witnesses to the effects of a truly powerful space weather event on human technology. They experienced firsthand the wild, untamed electricity coming from the sun, funneled through the Earth's magnetic field and into their equipment. It was a chaotic, dangerous, and utterly unique experience. It showed the fragility of their new technology and the immense power of the universe. The sparks and small fires were a vivid demonstration of just how much electrical energy was flowing through those wires. It was a wake-up call, not just for the telegraph industry, but for anyone who might have been paying attention. The sun, which seemed so distant and benign, could reach down and directly interfere with human affairs. The telegraph, the symbol of modern communication, was suddenly at the mercy of forces no one even knew existed. This was a true test by fire, both literal and metaphorical, for the nascent electrical age. The effects of the solar storm weren't just limited to telegraph offices. The sight of the aurora was a global phenomenon unlike anything most people had ever witnessed. It wasn't just in the far north or south. People in tropical regions who had never heard of the aurora suddenly saw the skies ablaze with color. Imagine waking up in a warm climate, looking outside, and seeing the entire sky pulsating with red and green light. It would have been truly unsettling, even frightening for many. Newspapers reported on the strange celestial displays. People debated what it meant. Was it a sign from God, a precursor to the end of the world? Superstitions and old beliefs resurfaced. Science was still too young to have a widely accepted explanation for such a grand and terrifying natural event. Even for scientists, it was a moment of profound realization. The sun wasn't just a distant light. It was an active body capable of sending immense amounts of energy towards Earth, energy that could visibly affect our planet. But beyond the telegraph, there wasn't much other technology sensitive enough to be affected. There was no vast electrical power grid like we have today, no satellites, no radio communication in the modern sense. So, while the telegraph system took a beating, other everyday life mostly continued as normal, albeit under a sky that looked like it was on fire. People were more likely to be wondering about the strange lights than worrying about their appliances. They didn't have appliances that could be affected by it, really. The immediate aftermath was a period of repair and reflection for the telegraph industry. Operators fixed their equipment. Managers tried to understand what had happened. They realized their long wires were vulnerable to something they didn't understand. It forced them to think about how they powered their lines and how they protected their equipment. It was a lesson in the unexpected vulnerabilities of new technology. This event, later dubbed the Carrington Event after the astronomer who observed the flare, didn't immediately lead to widespread scientific understanding of space weather. It took many more decades for scientists to fully grasp the complex interaction between the sun, Earth's magnetic field, and the resulting electrical phenomena. But it planted a seed. It showed that there was a connection, a powerful and sometimes dangerous connection, between our star and our planet. It highlighted that Earth wasn't just isolated in space. It was constantly interacting with its environment, particularly with the sun. For a brief period, the world experienced a direct, undeniable demonstration of cosmic power. It was a time when the sky became a vast, living canvas and human technology, for all its newness and wonder, was shown to be fragile. The immediate impact was on communication, the very thing that was supposed to bring people closer. But the broader impact was a subtle shift in perception. The sun, our life-giving star, had shown a new wild side. And for the first time, humanity had a clear, if puzzling, record of that power directly affecting its most advanced creations. It was a taste of what cosmic forces could do, a powerful reminder that we are part of a much larger, more dynamic system. The Carrington Event of 1859 became a legendary story in the world of science and technology. It still is. It stands as the most powerful documented solar storm to directly hit Earth since the dawn of widespread electrical infrastructure. For many years after 1859, the lessons learned were somewhat forgotten or not fully understood. Space weather science didn't really take off until much later, when more sophisticated instruments and theories emerged. But the event left a clear mark in the historical records, especially in the telegraph offices. What it truly taught us in the long run is about vulnerability. Even with the simple technology of 1859, the sun could wreak havoc. The event proved that Earth is not immune to what happens on its parent star. It showed us that there's a delicate balance. Our planet's magnetic field, which protects us, can also funnel energy from the sun into our systems. The Telegraph operators' reports, with their vivid descriptions of sparks, shocks, and self-powered lines, became crucial historical data. They provided first-hand accounts of what a truly massive geomagnetic storm could do. They were the ground zero for understanding this powerful cosmic force. Their experiences showed that even paper could ignite from the intense electrical surges, demonstrating the very real physical danger that these induced currents posed. Yes, there were small fires of paper and equipment, making the offices very dangerous places to be. Today, the Carrington Event is a benchmark. When scientists talk about worst-case scenarios for space weather, they often refer to a Carrington-level event. This is because our world is far more dependent on electricity now. If a storm of that magnitude hit today, the effects would be far-reaching, impacting power grids, satellites, GPS, and countless other systems that rely on stable electricity and reliable signals. The simple fact that a telegraph office could have paper ignite from sparks in 1859 gives us a glimpse into the potential for much larger problems with today's complex, interconnected electrical systems. The legacy of 1859 is a constant reminder. It reminds us that our technological advancement comes with new vulnerabilities. The sun, while vital for life, is also a powerful and unpredictable force. We have learned to watch it more closely. We have satellites constantly monitoring solar activity, trying to predict when the next big flare or CME might be headed our way. This field of study, called space weather, owes a lot to the observations of Carrington and the experiences of those telegraph operators. So, to answer the question directly, did a solar storm in 1859 set telegraph offices on fire? Yes, in a localized sense. Sparks flew from equipment, and small fires ignited on paper and telegraph tape. It was not widespread destruction of entire buildings, but it was serious enough to be a significant hazard to the operators and their equipment. The danger was real, and the experience was truly intense for those working the lines. It was a raw demonstration of how the sun's power, funneled by Earth's magnetic field, could directly impact human technology, even in its earliest, simplest forms. The Carrington Event remains a powerful story. It's a tale of humanity's early encounter with the raw power of space. It's a story about how new technology, no matter how amazing, can have unexpected vulnerabilities. And it's a story that continues to resonate today, pushing us to understand our place in the cosmos and to protect our increasingly technological world from the sun's unpredictable fury. It was a lesson written in sparks and celestial light, a lesson that continues to teach us about the profound connection between our planet and the fiery heart of our solar system.